So let's continue. I'm a senior software developer at Ping. I mostly work on session management and WAM solutions. I'm a technology enthusiast. I read too much about technology and too many things. I'm Canadian, so if you want to make, hey, thanks.
All right, represent.
If you guys want to talk about the Canadian stereotypes, come find me at the bar later today. And I'm a part-time dodgeball player. And by part-time, it's once a week for the season, and that's me at the playoffs. And if you haven't played it, go for it. It's going to be fun. So the agenda for today is I'm going to talk a bit about OAuth 2 protocols, what it provides and what it doesn't provide. Then what is OpenID Connect, some example use cases, and we'll go through a basic flow, which is going to be boring, but it's essential, and some best practices. And I hope I can get it done pretty quick so we can open up for questions. A lot of people are here that built the protocol and implemented the protocol, so they can answer a lot of questions. So let's get started. Okay, so OAuth 2 review. So this is a diagram of an OAuth 2 implementation. There are 4 major actors in OAuth 2. It's the resource server, first and foremost. It's a server that protects a resource, an authorization server that provides an authorization for an authenticated resource owner, a client that can be an application or any other thing that can make a call on behalf of the resource owner, and the resource owner, which is an entity that has granting access to the protected resource. So the client makes a request on behalf of the resource owner to the resource server to do something, whatever that thing is. And basically, OAuth 2, as it's mentioned in a lot of places, it's a delegation protocol. It delegates the grant from a resource owner to the client. And what is and what is not OAuth? So OAuth 2 is not an authentication protocol. It's not a federation protocol. It is an authorization protocol. And what if you want to do authentication? There's no defined token types. There's no standard way of doing token validation, and there's no session management. With that comes OpenID Connect. Pam, do you want to go through anything on this?
Sure, just a little bit of color on the OAuth 2 stuff. As an example, because often people hear client and client doesn't mean anything to them. The difference between federation and SSO that you might be familiar with is that it's what's called passive. It's a passive protocol. So what that means is that the browser is acting as a user agent, right? But it's not an intelligent user agent. It's not capable of acting on its own. It's just following the buttons that you push. With OAuth, you have a client that can be active software. So it may be running a whole program, right, that the user is not even necessarily aware of, right? It could be doing searches in the background and all, like a mobile app is a perfect example. And so the difference between federation is an introduction, and what Jim's just described here is delegation, in that you've got a piece of smart active software that's being granted a small amount of permission to do a small amount of thing on behalf of the user. So there is no, how the user authenticates to grant that is a question of all the flows of OAuth and all the ways that OAuth can redirect to, for example, an identity provider to do that kind of authentication. That'd be my color code.
Cool. So here comes OpenID Connect. Introducing OpenID Connect. So OpenID Connect tries to easily and securely answer to the following question: what is the identity that the person currently using the browser or the native app has? What is the user's identity? It is built on top of OAuth 2 protocol. It uses similar stuff and tools like JSON and HTTP and Jose and so on. It adds an ID token, which is a jaw token on top of the response coming back from the authorization server. And it gives API access and SSO all together. And this is the stack. The underlying part is OAuth 2 and all it provides. And on top, there are the core fundamental parts of OpenID Connect. It's the core, the discovery, dynamic client registration, session management, and form post-response mode. And implementers can decide how much of this they want to provide in their product. A minimal implementer just can have the core. It can have the core discovery and dynamic client register to be a dynamic compliant, and you can build the whole suite and be complete.
Yeah, I would also add just that, depends on your use case, right? The more security you want to add, the more encryption goodness you want to add, the more bits of this you can accumulate. So they compose together to make an entire suite, or you can just use the simplest pieces. That's sort of part of the power of the framework.
So OpenID Connect is built on top of OAuth, and what it does is a client makes a request to an authorization server based on some flows that we will see later on. Eventually, it will get an access token and an ID token. The ID token represents the user's authentication information, and the access token can be used for delegation again, and it can be used on a specific endpoint that's part of both authorization server. Actually, it's implemented on the authorization server, but it is a resource that's protected by the access token that provides user information, user attributes like which AD groups, email, and so on and so forth. And the request and responses is a simple RESTful request and response is a normal JSON response.
Yeah, one thing, so the security characteristics of this mechanism are really good, right? Because the first thing is that you don't get a password or any kind of user credentials passed on the wire to the resource service. So OAuth 2 alone will isolate your credentials from your resource server. What OpenID Connect does is takes it another step. It allows you to actually send an assertion to your client. So now your client has identity information, whereas in OAuth, all you get in OAuth, you make a blind request for an access token. You get an access token back. You don't know anything about the identity of the user behind it. You just know you can use it to make API requests. So having that ID token on top as an assertion is what enables single sign-on and enables all the stuff Jim was talking about.
So the features added on top of OAuth is having the ID token to basically represents the user's authentication information, a user info endpoint to provide user attributes using that access token that it's obtained through the OpenID Connect flow. An endpoint discovery, this is part of the discovery part, and it provides information about the OpenID Connect provider, like their authentication endpoint, the token endpoint, their user info endpoint, the JWKS endpoint that provides the public keys that are used to sign the ID tokens, the JSON web keys, which again, it's part of the JWKS endpoint and can be fetched by the client in order to verify the signature on the ID token, session management, and dynamic client registration. Do you want to add anything?
No, keep going. You're on a roll.
So with that said, I'm going to go through two use cases. This morning, Patrick said that a picture can describe 1,000 words, I'm going to draw a picture with 1,000 words. So sorry about that. The first use case is, and by the way, after drawing the picture with 1,000 words, I'm going to actually go through this step by step, so don't worry about that. The first use case that I'm going to go through is a web login for a web application. So let's say you have a web application and a user wants to log into it. What happens if you do OpenID Connect? The first thing is the user clicks on some sort of link, or the user actually hits that page, and it gets redirected to the authorization server with certain arguments. After that, the user is prompted for the credentials, and puts in the credentials. That's part of the authentication flow. It can be, or it can not happen. The user can have a Kerberos ticket or already have a SSO session. So this is part of the authentication. And then in some cases, authorization servers show a consent form to the user to approve the scopes that it's going to give access to the client. After that, a redirect happens to the callback endpoint with the auth code. The auth code is the little code that's used to obtain access token and the ID token. And at this point of time, the ID token contains all the authentication information that the web application may need to create its session. Now, the web application makes a call to the user info endpoint, gets using the access token, and gets the user attributes back. At the end, everything that's required, and it's provided and required for the web application to create a session on behalf of the current user, it's all there. And the session can be created, and the user can continue working on the website.
There's a few interesting things about this that are really important to recognize. First of all, the web application never does see the credentials of the user ever. So that web application redirects, it gets an ID token back, and it gets an access token it can use for follow-on API. So as far as it's concerned, it's asking for something, it's getting back a thing it can use to both validate the user, validate the issuer of the token who's actually standing up to say who the user is. That's all they have to care about, right? If the downstream resource server tries to validate the user, that's great. But again, no credentials are passed on the line, only an access token, which can be revoked and which only represents partial access. It's not something that can be used to impersonate the original user. And then the authorization server is the thing that's responsible for doing the authentication. So now you have a central authentication point that's heavily watched, heavily audited. If an attacker tries to go to 10 OpenID Connect protected resources, they all end up back at the same authorization server. So in theory, these kinds of attack patterns can be detected.
Thanks. So the next use case is for mobile apps, and this is pretty interesting. So let's say you have a mobile app, and I open it up, and most of the mobile apps these days have their username, password, credential form, if they need it, in the main page. But let's say you want to do SSO, and there are at least 24 talks about this that I know of, that how we can actually achieve that, and I'm trying to represent that. So what the user basically would do is try to authenticate through the mobile app. So the first step is the user initiates the authentication flow on the mobile app. What this will result to is from the best practices of today, a browser will open up, or a modern web view, which has shared session and was introduced in iOS 9, and the latest versions of Chrome will show up. This way the user knows that where they are going, it's not a blank web view. It has a lot of information. So again, the mobile app opens up the browser or the modern web view, and it is recommended to use Pixie, and we'll talk about Pixie a bit later. The user is prompted for username and password. This is happening on the authorization server, so the app doesn't know anything about it. There is a consent form again to approve the scopes that are passed to the user, and then the authorization server calls a callback to the endpoint that the app is registered to, the custom schema, with the auth code, or it can be through the browser too. Eventually, the mobile has a authorization code, so it can exchange that with for an ID token and an access token. And if it uses Pixie, it can use the Pixie. It should use Pixie token here as part of that exchange. Eventually, the ID token is present at the app level, and the app can use it for managing user sessions or other information. And the access token can be used to call the web user info endpoint for attributes. Plus, it can be used to make API calls to the protected resource. And usually, the modern day applications use OAuth flows to make calls to their API, and the same access token here can be used for that if it's implemented in the right order. And with that, do you want to include anything on this one?
The only thing I would talk about is there are two basic flows in OpenID Connect. There's what we call the code flow and the token flow. So what we have here is the code flow, right? So what Jim was talking about was the fact that instead of just getting a token back right in the browser where it might be intercepted, the code flow idea is that you get back a one-time use, very, very short-lived artifact called an authorization code, and then you make a RESTful call to a back-channel call to trade that small artifact for your actual information. So it's up to you as implementers as to whether you want to use the authorization code flow or in the token flow, the browser delivers the tokens right to you. So there's a selection of things if you go through and read the spec. You can choose what security model matches the best for your phone. And of course, the big thing about a native client running on a phone is that you have to decide whether you're going to designate it as a confidential client or as, I think it's public client, is it the other one? So, there's a real decision under that is, can that client be trusted to keep a secret? So if you have a way to store a secret that you can use as a RESTful credential to make that back channel call to fetch your token, then you're better off, in my opinion, using the code flow. Some people, for example, if you're running a JavaScript widget, then there's nowhere to store a secret. And so you're better off trying to make very, very ephemeral grabs of tokens, right, very, very quickly, rather than trying to go for a security theater approach of pretending there's a secret that's not really secret.
The token flow is the implicit grant type?
That is correct.
That's correct.
Exactly. Sorry, for anyone who didn't hear that, the other name for token flow is implicit grant type. Do we want to take any other questions right now? We could.
Yeah, we can stop. Yeah.
Yeah.
Any
anyone
other
else
questions?
have any questions on what we've done so far?
Sure.
The SLO is pretty finalized yet. I mean, the back channel station revocation looks good. Front channel SLO is it finalized?
So the question is on the SLO specification. It is not finalized, to my knowledge, unless someone finalized it when I wasn't looking. And they're going to talk more about that a little bit farther along. So I think, John, you'll probably address that a little bit in your talk, right?
That isn't my talk. But
Okay, then the answer is.
the question again.
The answer.
Answer any question.
Yeah. Okay. So no, it's what we're talking about is the session management spec, and that spec is still under review by the working group. So no, it hasn't been ratified yet. It'd be lovely if it had. So, any other questions before we? properly to answer that question. The people in the room are here, but I don't know if I can even rephrase it well enough. So you're asking what security checks and balances from what we've talked about
Yes.
are common best practices? Is that?
Yeah, that and any type of like, I guess tie-ins clients or like just anything run like for like Splunk or anything like that as far as
You mean
doing those checks.
as far as, yeah, I mean, so this is actually an excellent question. So the question is, are there any tie-ins to products and companies who are using this spec? And the answer is absolutely. So there are conformance and certification tests that are being developed right now in the OpenID Foundation. And in fact, Mike Jones is going to talk about that in the next session. The spec is very, very specific about what you validate in order for this whole flow to work. So the absolute worst thing you can do is what I call a hello world client, where you accept an assertion. You just accept and you accept and everything's great. You never actually, check anything or deny anything. So the problem is, it looks wonderful, right? The people authenticate and they get in, but what you don't, the true measure of an OpenID Connect client is not what it accepts, it's what it denies. So that's why the certification is absolutely critical. And there are quite a few companies using it today. I believe Facebook uses an older draft of the spec. They're not perfectly spec compliant. Microsoft is working on this. Oracle, I believe, has this. Google.
Us.
Us, absolutely. Okta has it as well. There's probably 10 more people in the audience. So yeah, it's quite a groundswell right now in adoption. So, one here.
The access token return.
Access token
Still-
return. Yep.
Still the same non-defined token out of the original OAuth 2. Is that correct?
You want to take this
What-
one?
Yeah. So
Uh,
it
My
can.
problem is, if my resource server
Mhm.
is actually profile information, user information for authorization purposes,
Right.
I encountered numerous products where basically the access token is a random string only known to the authorization server. So that forces the resource server to go back.
Right.
There's no way to validate the access token. What's the reason behind that?
Actually, there is a solution to that. Let me just repeat the question so that everyone can hear it. So there's a concern around access tokens because they are defined as, on purpose as being opaque. So the client doesn't know what the access token is supposed to have in it. It only knows it asks for it, and then it replays it to the resource server. The resource server has to know what to do with it, and that's the.
Yeah, but the resource server doesn't necessarily know it directly, neither.
Yeah, so the question is, how do you tool that resource server? Because it is beyond the spec.
You want to go ahead with this?
Sure. Well, right now there are basically. Are we time constrained? Okay. We have more time on the clock, but we can
Okay.
definitely do that. I'm glad we stopped when we did,
Yeah.
actually. So there are two ways you can do it. You can use what we at Ping call reference tokens, right? Which is an abstract token, and you make an API call to the reference. Or you can use JOT tokens, which are self-signed encrypted JOTs that can be validated directly at the resource service. So you do have, and there are actually other options as well.
Token introspection.
No,
The
but
token
What
introspection.
I'm wondering, I know that Ping is very active in the standardization process. Why didn't you go ahead and make the access token a defined, or actually merge identity and access token?
Well, identity and access tokens are separated on purpose, absolutely on purpose. So the ID token is meant to communicate identity and session information to the client. The access token is meant for the client to play to the resource service.
So I'm looking for a scenario.
You're looking for the
where
follow-on scenario.
I actually have an identity token.
Okay, well then that's actually possible. So that's called the hybrid flow. And the hybrid flow is the idea that the client can actually request not just an ID token for themselves, but they can actually request an authorization code that they can pass to the resource server or pass downstream and have that downstream entity then retrieve their own identity token. So that's probably something that would go farther in the advanced spectrum, but we can talk about that. And I mean, there are people here who can map the whole thing out for you. But that's a use case that people have talked So, okay, so do we need to cut and run right now? Okay, well,
Why don't you tie it together and we'll.
So I'll just go through all this stuff that didn't have time to go through it. And if you want to talk about these things, I'll be happy to talk about it. But there is a much important slide at the end that I want to go through.
it's like,
Come on, best practices, there it is. So there are a few things here that I personally used as best practices, and these are passed to us from the industry leaders. First and foremost, always use state and nonce. That's for sure. Always ask for the user's consent. Use developer libraries. There are multiple development libraries around there. Microsoft has their own. As far as I know, Google has. We have a few things, and so on. If possible, use the basic flow, the authorization code flow. The security model on that thing is excellent. Use Pixie if it's available, and this mostly applies to mobile applications. Whatever you do, don't expect the client secret to be secret. It's part of your code this applies to mobile again. It's part of your code, it's in the app, it's in people's mobile phones. And use a system browser or the modern web view, and do not use embedded web views. This just caused a bunch of confusions. And the embedded web views, headers and everything,
Well,
and there is no common session.
they preserve the sandbox too, which means you have options for single sign-on that don't exist if you use an embedded web view as well. So, all right.
And with that, thank you, everyone, and I will be happy to take questions later on today. I bet
Sweet.
Pam does
Big
too.
hand for
and
Jim.
Thanks.
Nice work.